work. We will now try to understand the concept of work by observing various scenarios. Not so much work in spite of working hard. In this section, we will try to understand the meaning of work in physics and how it differs from our general conception. Scenario 1. Imagine a student studying for an exam. If the student is studying for long hours and putting in a lot of effort, we say that the student is working hard. But in a physical sense, the student may not be working much because the amount of energy spent is less. Scenario 2. A boy is pushing a very heavy object. After he tries for a long time to move it, he becomes very tired, and even though the rock hasn't moved, if we analyze the situation in a physical sense, the work done on the rock is zero. However, the reason why the boy gets tired is because of the continued contraction of the muscles of his body. Scientific conception of work. We will now look at some scenarios. Push a block of wood across the table. Work is done in the block. If you lift the same block vertically from the table, you apply force to counterattack the force of gravitation and doing work as a result. From these observations, two primary requirements can be established if work is to be done. There must be force acting on the object and the object must displace as a result of it. Imagine an object is placed on a flat surface, say a table. If a force of F units is applied on it, the object is displaced in that direction by a distance of S. Then the work done is equal to the product of the force and the displacement. Work is scalar quantity, which means that it has only magnitude and no direction. If a 1 Newton force applied on the object creates a displacement of 1 meter, then the work done is 1 Newton meter or a joule. We notice here that the angle between the direction of the force and the direction of the motion is 0 degrees. What if the direction of the displacement is opposite to the direction of the force applied? In this case, the angle between the force applied and the displacement is 180 degrees, and the work done is defined as minus F times S. For this activity, you will need an object that is light enough for you to be moved. Take the object and lift it into the air. When the object moves upwards, two types of work are done on it. The work done by the hand on the object is positive because the displacement and force applied are in the same direction. Along with this, there is also a force of gravitation that is acting in the downward direction. The work done by this force is negative because the direction of the displacement is opposite to the direction of this force.